We used, for the previous class, we used that technique there, which was using delta x. Now, it may not be a wise option for the exam because there's too much of simplification involved there. So let's assume now we are dealing with this question here, the same one. We're going straight to the y-axis here. Right, so we are rotating around the y-axis. So, what happens if we are using delta y? Here's my delta y here. Now, can you see that? If I am using delta y, so let's write this down. So I know that delta y, how is it in relation, how is it positioned in relation to the y-axis? How is it positioned? Is it perpendicular or is it parallel? It's going to be perpendicular. Now there's it here, perpendicular. So I know delta y is going to be perpendicular to the reference axis. Therefore, I'm going to use the formula I is going to equal to mk squared. Therefore, for volume, what method am I going to use? I'm going to use the this method. Right, so let's see how this is going to work. Now, if I am using delta y, I definitely need to know what is the y value at this point, what is the y value at that point there. Right, we can work it out. We know what is x here. What is x at this point here? X is 4. We know x at this point here is also 4. So, how can I work out y if I know what is x? I will substitute it here and work out y. So let's just work that out first. So I know that y squared is equal to 4x. So we want to know when x is equal to 4. So y squared is equal to 4 times 4, which is 16. So y is equal to plus or minus the square root of 16, which is equal to plus or minus 4. Right, so we know now that this is going to be a 4 and minus 4. Right, so now let's get to working out the moment of inertia. Right, so we know that we are using mk squared there. So your moment of inertia, delta I, which axis? Y-axis, so it's going to be delta Iy is equal to mass, which is delta m times your k squared, where you know that k is equal to the radius divided by root 2. Okay, so what do we know? Mass is equal to density, P times volume, which is delta Vy, because we are rotating around the y-axis there. Can you see that? Okay, so now, times your k squared there. So now, volume, what method are we using here for volume? We are using the disk method. So, it is going to be the volume of the top graph minus the volume of the bottom graph. Okay, because there's two graphs we are dealing with here. So, this graph here is going to be the top graph, and this one here, the straight line will be the top graph, the parabola will be the bottom. Okay, so now let's see how this is done. So we need to label it. Let's label it properly. Okay. Let's call this one here. Let's call this x1, and let's call the parabola x2. Okay. So now we are rotating around the y-axis there. Can you see that? We are rotating around the y-axis, so therefore the radius is measured in terms of x. Alright, so let's go here. So we know our radius is measured in terms of x. Now, our top graph is x1. So this method is going to be pi. Remember, it's pi r squared times h. So it's going to be pi x1 squared minus x2 squared times the height, which is delta y, times k, which is x all over root 2 all squared. Okay, so now let's see what happens here. We're going to get p pi, that is x1 squared minus x2 squared times delta y, times, we will square this, that will be x squared over 2. Alright, so now let's write this down neatly for our total. Take all the constants, we got p, pi, and we got the 2 there, so that will be p pi divided by 2. We are integrating with respect to y, so that's going to be d and c, and now x1 squared times x, or x times x squared will be x1 to the power 4 minus x2 to the power 4, and that is dy. Okay, now let's substitute. We got p pi over 2. What are the y values that we are dealing with here? We are dealing with a positive 4 and a negative 4. Can you see that? So that will be 4 and minus 4. What is my x1? What did I call x1? x1, there's x1 here. What is x1 here? x1 is 4. So this is going to be 4 to the power 4. Can you see that? Minus x2 to the power 4. Where is x2? x2, there's x2 here. So we need to manipulate this one here. So we know that x2 is equal to y squared over 4. Okay, what do we want? We want x2 to the power 4. So x2, if I raise it to the power 4 here on the left hand side, that means I need to raise it to the power 4 on the right hand side. Can you see that? So now x to the power 4 is equal to, here we have a power raised to a higher power, exponent law, you multiply, so that will be y, 2 times 4 will be 8, and this is 4 to the power 4, 256. Okay, so this is going to be y to the power 8 all over 256. And there is my dy. Alright. So 4 to the power 4 there, that is 256. So when we integrate it, that is going to be 256y. Okay. All over 2 here. Sorry, I forgot about that. So now when we integrate this, 256y, so this will be y to the power 8 plus 1 is 9 all over 9 times 256. What do we get there? 2304. And then we need to substitute 4 and minus 4. Okay. Okay, so let's use a calculator there for substituting 4 and negative 4. Well, then let me this calculator here. Right, so here I get 8192 over 9. Yes. Right, then I will substitute minus 4. You get minus 8192 over 9 there. Okay, so this is now equal to 1634 over 9. 1684. 16384 over 9 times pi over 2. Times pi over 2, we get 8192 over 9 pi times p. Did we get it here? Where is our answer here? Where is our I, X, I, Y here? Let's trace it. Here's it here. 8192 pi over 9p. You can see we get the same answer. Right, but it was much easier to get it here compared to there. You can see that. So now, in terms of the mass, so this is going to equal to 8192 over 9 pi, and we know what is P. P is M over V. We need to work out V. There we used the shell method, here we're going to use the disk method. Alright, so what is V now? Here is your V here. Here is your V here. So there's it. All we're going to do is extract this information. Let's write it down here. So Vy is going to equal to pi. That is D and C x1 squared minus x2 squared dy. Okay. So that's going to be pi. It's the same D and C. Same D and C, which is 4 and minus 4. What is my x1? Where is my x1? What is x1? x1 is 4, so that becomes 4 squared minus x2. What is my x2? Y squared over 4. But this has to be squared there. We need to simplify first. Right, we need to simplify this first. So 4 squared is 16 here. We got a fraction, y squared all squared will be y to the power 4, and 4 squared will be 16 there. Okay, let's integrate this. Integrate 16, that will be 16y. Integrate here, this will be y to the power 5 over 80. Substituting 4 and negative 4. Let's see what we get. Here we get 2, 5, 6 over 5. When we substitute the positive 4, when we substitute the negative 4, minus 2, 5, 6 all over 5. So basically it's like multiplying by 2 there. You can see that. So we get 5, 1, 2 over 5 pi. Did we get it this side? Yeah. There's a check. Can you see that? Same thing, different technique. So what do we do now? We are going to substitute here. No space for substitution. Let's just erase this here. Right, so from here, your I, Y is equal to 8192 pi over 9 times M over V. There's our V here, which is 512 over 5 pi. You can see it's exactly the same thing there. You should get 8 comma